Pre-calculus, I'm back. We've got more limits to discuss today, and this might span 2, maybe 3 videos. Okay, so let's get to it. This is piggybacking off of kind of the tail end of the limits I talked about in the previous homework assignment. So if you remember, let me take a random infinite limit like this and say, what if we're trying to compute the limit as x approaches infinity of 2x squared plus 7 over 3x squared plus 8x plus 9. All right? If you'll recall, we divided both the top and bottom of this fraction by the biggest power from the bottom. Okay? So the biggest power from the bottom was x squared. So I would divide this by x squared, this by x squared, this by x squared, and then everything on top by x squared. And what that did for us is it created either constants or expressions with x's on just the bottom. We also talked about how anytime you are approaching infinity for a limit, and there's like an x that's on the bottom, you are approaching infinity so fast that it's basically like saying, this has no value. 7 divided by infinity, there's no value to that. It's 0. So it zeroes out this part, and this part, leaving you with just the constants. Because the limit as x approaches infinity of 2/3 is just 2/3. So the answer was 2/3. We're going to do something similar to work through expressions that have square roots on them. So let's get to it. What's the biggest power on the bottom of this expression here? It's x. So you'd take 7x divided by x minus 9 divided by x. Now this is really tricky. You are left with a square root expression. How do you divide that by x? Here's how. X is the same as the square root of x squared. So technically, if I divide 2 square roots, then the parts of the original square root can now divide with this part right here. So I'm going to divide the top by root x squared. So here's what happens next. A root divided by root means I can just now encapsulate this whole thing by 2 divided by x squared, negative 3x divided by x squared, and 11x squared divided by x squared. And then the bottom's going to be 7 minus 9 over x. Now, when we investigate that further, and again, we're talking about a limit here, so perhaps I should bring the limit back. You've got 2 over x squared. This becomes minus 3 over x, and this is just straight up plus 11. You can still apply the limit as x approaches infinity to the parts inside the square root. It's almost like you're plugging it in. So this part right here, that zeroes out. This part right here, that zeroes out. On the bottom, that part right there will also zero out, leaving you with 0 minus 0 plus 11. Underneath the root, divided by 7. Kind of tricky, but this is really the only trick you had to use. Now, technically, I should explain one nuance to this that wasn't shown on number 1. Technically, the square root of x squared doesn't equal x. It equals the absolute value of x. Because there was a rule, and this might have been a while ago for you guys, but when you take an even power of an even root and it reduces to an odd power on the outside, you technically have to use absolute value bars for reasons that would probably take a few minutes to explain that I don't want to on this video, okay? So technically, we should have been dividing both the top and bottom by the absolute value of x, which is still root x squared, but it's kind of like, how do I take 7 minus 9 over x? Or how do I take 7x minus 9 divided by the absolute value of x? And here's technically what we assumed. If you're approaching infinity, positive infinity, you're technically talking about the line y equals x. Okay? When x approaches infinity, its behavior, because remember the absolute value graphs? They look like this. That is the part that you were dividing by, which basically mimics the behavior of y equals x. That's why we divided by positive x. Now, when the limit approaches negative infinity, we're no longer talking about this behavior. We're talking about the behavior of y equals negative x. So here's what we got to do. If it's the exact same situation, I basically copied and pasted this, so same thing. You are now, because of the negative infinity right here, dividing the top. I mean, it's still the square root of x squared. Okay? The bottom, 7x minus 9, that's going to be divided by the absolute value of x's behavior when you go to negative infinity, which is the line y equals negative x. All right, so that can be kind of tricky. You really have to keep your wits about you when you're computing these limits, or at least going through that process. Now, I'm going to skip ahead here because we really did the computations already for this. We know that this is going to just be 2 over x squared, which is going to zero out, minus 3 over x, which is also going to zero out, plus 11. This is all that's underneath the square root. Okay, and on bottom, now instead of positive 7, it's going to be negative 7. No, this really doesn't change that part. It's going to make it plus 9 over x. But again, when you're approaching either negative infinity or positive infinity, the bottom is so astronomically large that it's just 0. So this is root 11 over negative is 7. So that's the answer to number 2. Okay, now, what if it's not just a square root with an x, like an x on the bottom? What if it's an x squared on the bottom? What if it's an x cubed on the bottom? I wanted to show these examples so that we could really flesh out this idea. So if it's positive infinity, we know right off the bat that we're going to divide by just regular old x squared on the top, or I'm sorry, on the top and bottom. So the bottom is 9 minus 7x squared. We're going to divide by the biggest power on the bottom, which is x squared. Now you got to ask yourself the question, what is the equivalent square root that would yield x squared? And hopefully you guys figured out that that should be x to the fourth power. Okay, so we're taking this square root, not divided by root x squared, but root x to the fourth power, which basically is going to create a larger square root of division. So 2x to the 4 divided by x to the fourth power minus 3x over x to the 4 minus 5 over x to the fourth power. Okay. And at this point, I think you guys, you can kind of look ahead at what's going on here, right? These two are going to cancel out, x to the 4 over x to the 4. This is ultimately going to have an x cubed on the bottom when we simplify it. And this is, this is also going to zero out as well. These x squareds are going to cancel. And this one will zero out also. So what are you left with? You plug in an infinity. You've got a root 2 on the top. You've got a 0 minus 7 on the bottom. And that's the answer that comes out of that. Now here's the really tricky part about this second piece. All right? Before, we were talking about how, hey, you're supposed to do root x squared is equal to the absolute value of x. So why didn't you say root x to the fourth is equal to the absolute value of x squared? Well, here's the reason why. X squared can't be negative. I mean, think about it. Here's what x squared looks like as a graph. Where's that below the x-axis? Where is that negative? Nowhere. How can I take a number times itself and be negative? You can't. So this whole idea that this will yield both a positive x squared and a negative x squared is not on the table anymore. So you can go to positive infinity and get root 2 over negative 7. You go to negative infinity, and if it's this situation with root x to the 4 and x squared for these two parts, that negative infinity makes no difference at all. You have to have an odd power on the bottom here in order to create that negative infinity means divide by negative. So, this is still going to be 2x to the 4 divided by x to the 4 minus 3x over x to the 4 minus 5 over x to the 4 over 9 divided by x squared. We're not negating it just because it's going to negative infinity, because this will never be negative. You'll never have a negative x squared versus a positive x squared. Always positive. So that's interesting. It's the same answer for this particular situation. Because that cancels, this is 0, this is 0. That cancels, this is 0. All right, we're going to continue this on the next video, so I'm going to just click stop and then click start right away.